Hello, everyone. Welcome to day 3 of Coalesce. My name is Elise Papineau. I am a senior analytics engineer at DBT Labs, and I'll be the host for this session. The title of this session is The Future of Analytics is Polyglot, and we'll be joined by Caitlin Colgrove, who is the CTO at Hex. Hex is a polyglot data workspace for teams. Before we get started, all of our chat conversation for this session is going to take place in the hashtag coalesce-polyglot-analytics channel of DBT Slack. If you're not a part of the chat, you have time to join. Visit community.getdbt.com and search for the coalesce-polyglot-analytics channel when you enter this space. We encourage you to ask other attendees questions, make comments, and react in the channel. We're all here experiencing this together, so let's interact together in the channel. After the session, the speaker will be available in the Slack channel to answer any of those questions that you have. Let's get started. Over to you, Caitlin.
Thanks, Elise. Hi, everyone. I'm Caitlin. I'm the CTO over at Hex. For those who haven't heard of us, we are a data workspace for teams. And as part of my role at Hex, I get to spend a fair amount of time thinking about how we can or should focus on incorporating various different technologies into the product. That's the T part of the CTO. And today I want to talk about one specific area of that, which is the use of programming languages in analytics workflows. So this is definitely an area where I'm still learning new things every day in this space. So rather than kind of talk your ear off for the whole 30 minutes, I'm going to give my brief take on where I see things today, where I think it's going, some interesting technological trends that we're seeing. And then I'd love to transition the discussion over to Slack and hear from you all what you think I got wrong, want to talk, want to argue, and just hear more about where you think the space is going. But to get started, I think it can be helpful to take a little bit of a walk down memory lane and look at the history of code and analytics. So in the beginning, there was SQL. It's almost funny with this big resurgence in SQL. I know we're all here at Coalesce, we're all big SQL lovers, and it's sometimes easy to forget that SQL is actually a very old language. It was developed at IBM in 1974 for use with, at the time, the equally new technology of the day, which was relational databases. And SQL was this huge revelation. It was a big step up from all of sort of the previous query technology, because the fundamental innovation was that you could specify which data you wanted as distinct from how the data was actually retrieved on the server, which meant that a lot of the complexity around querying data could be hidden away at the database level instead of requiring the programmer or the analyst to reason about it. All right, so let's keep going. Moving into the 80s and the 90s, we see this rise of a brand new technology, the first breakout example being Lotus 123, which I don't know how many of us here are old enough to remember that, but I am sure, on the other hand, that we are all familiar, whether we like it or not, with its far more popular and long-lasting competitor, which is, in fact, Excel. So spreadsheets aren't often grouped with other programming languages. I think in a lot of cases, they're seen as kind of less sophisticated, but especially towards the upper end, they're really quite powerful. So for example, in Excel, you can do things like write VBA, which is in itself a full-fledged programming language. Spreadsheets were great. They were a lot more approachable than SQL at the time because you didn't have to learn a whole new language to get started. And with newly ubiquitous operating systems like Windows, spreadsheets were extremely portable between computers, which made collaboration very easy. So as a result, spreadsheets were the dominant technology in business analytics through the 80s, the 90s, into the 2000s. And you could even argue that despite all of the innovation in this space, despite the thousands of people that are at this conference today talking about SQL and various other languages, that they're still the most dominant analytics technology today, especially in particular disciplines such as finance. That's some pretty incredible staying power for any technology, quite frankly. Looking about 10 to 15 years ago, we have this revolution in data science. Workflows suddenly get a lot more complicated. We're talking about ingesting and cleaning data, training models, doing things at scale for the first time, really. And this just required a much more powerful set of tools than the spreadsheet could provide. So this time frame is where we see the rise of full-on programming, and the big ones being Python and R, but there's a bunch of other entries here. MATLAB is another classic example here. And these became really common and sort of ubiquitous among data analysis. Not only are these languages much more flexible and powerful than the types of things that you can do in a spreadsheet, but they also have a very rich library ecosystem, which is a new development. And a lot of these libraries were designed specifically for data science and visualization. You have pandas, you have ggplot, and so these are often usable with a single import statement. So every time you move to a new project or team or whatever, you're no longer reinventing the wheel, which is huge. Using programming language also has another great advantage, which it allows you to adopt more software engineering practices to help manage the increased complexity of the projects that came with these higher end data science workflows. All right. About 5 years ago, we see this huge resurgence in SQL, and this has been driven by a lot of tools like dbt that allow you to take a fairly actually small amount of code comparatively and power these incredibly complicated and powerful workflows. It is worth calling out that this is not your grandmother's SQL. We've learned a lot in the past 50 years, and today's SQL tools come supercharged with a lot of powerful new features. So one example that you can see here is Jinja templating, but they still retain a lot of the benefits that early SQL developers envisioned. The fact that SQL is a bit more on the rails than Python or R, it doesn't give you complete control over the implementation, is actually truly an enormous advantage because it makes the language really approachable to get started with, and then on the back end, much more portable and scalable. So you combine that with the engineering practices forged in Python and R, and you have seems like a pretty compelling set of workflows here. All right, so fast forward to today. Unfortunately, all of these paradigms, spreadsheets, Python, SQL, they have their own devotees. Teams are often divided internally between multiple languages. You have your SQL gurus, you have your data scientists working in R and Python, you have your people over in finance using your spreadsheets. Workflows often spread across multiple languages. And often this requires using completely different, completely incompatible tools. Iteration across these workflows is really challenging, as is collaboration. Overall, it's generally a mess. So how do we deal with this? One proposed solution, obviously, would be, why don't we just insert my language of choice for everything? This is appealing for a lot of reasons. You'd only have to learn one language, you'd only have to use one piece of technology, but unfortunately, in practice, things when you try to do this get really ugly. There's a reason that all of these languages are still around. It's because they're good at different things. So quick SQL versus Python example. So fun fact, it's actually provable mathematically that every program that's implementable in SQL is implementable in Python and vice versa. In computer science, this is called Turing completeness after Alan Turing. But even though that's true mathematically, in practice, the amount of effort that this requires can be wildly different. For example, training a model in SQL. This is a really simple example. This is just a linear regression, but you can imagine TensorFlow, all of these really complicated modeling libraries. It's theoretically possible, but in practice can be extremely difficult, bordering on impossible, and really just generally not how you want to be spending your time. And maybe someday someone's going to invent a language that elegantly solves every programming problem. By the way, if you're working on such a language, let me know. I'd love to be your beta tester. But I think until I see something like that, it's best to just assume that this polyglot environment will be true for the foreseeable future, and that some languages will inherently be better at certain things than others. And that if you try to wedge everything into a single language, it's actually going to wind up being more complicated than if you just use the right language at each step. Okay, so what is a better solution? For this, we take wisdom from the internet and we ask ourselves, ¿por qué no los dos? And indeed, why not both? For me, having worked with many of these paradigms and observed these different trends over the years, I'm very convinced that the only way forward is to embrace the fact that the world of analytics is inherently polyglot. And looking at the way things are moving, I'm convinced that the next era of data will also be polyglot. In this context, polyglot, we're really just talking about using multiple different languages in the same workflow. And this is definitely easier said than done. I don't really think we've seen the full potential of what polyglot technologies can be. And in the last few years, there's just been so much movement and development in this space. There's a lot of really exciting stuff going on here that's going to make operating in a polyglot manner much more tractable than it was even 5 years ago. So a couple technological highlights here. So the first one is this technology called Apache Arrow, which it's being developed by Wes McKinney, who also incidentally created this other library. It's obscure, you might have heard of it. It's called Pandas. But Arrow's goal is to be a cross-language development platform for in-memory data. Okay, so what does this mean and why is this cool? First, you can think of Arrow as a universal data frame format that can be read by any language. Previously, a lot of workflows were reduced to passing CSVs around, which is extremely limited and very slow. Arrow optimizes the heck out of this, which makes it an excellent choice for implementing polyglot systems. And it's actually, in fact, what we use for our backend interchange format at Hex. But Arrow also takes this one step further. For most languages like Python and R, objects have different layouts in memory, which means that typically to move things like data frames between languages, you actually have to completely rewrite the underlying data structure, which is a process that scales with the size of the underlying data. Arrow completely eliminates this, and in certain cases is actually even more highly optimized, which makes for transfers that are hundreds of times faster than other formats. Arrow at its core is a data frame, but it also has one additional very cool feature, which is the Data Fusion project. So the Data Fusion project allows you to query Arrow data frames with SQL as if it was a database. In a similar vein, DuckDB is a project that builds itself as, pun intended, an extremely fast in-memory database, which it absolutely is, but it also has this killer feature that you can feed it a Pandas or Arrow data frame, and without any additional overhead, using technology like the zero copy format that we just talked about for Arrow, you can then query the data frame with SQL with no performance penalty for the translation. Obviously, this is huge. I'm sure everyone here has had a moment where we were like, oh, this is so hard in SQL, I wish I could just use Pandas, or this is so hard in Pandas, I wish I could just use SQL. Now you can. It takes a bit of implementation, but over the summer, actually at Hex, we shipped a feature that we call Data Frame SQL, which does exactly this. And as you might imagine, it's been by far one of our most popular features. One other trend that I'm finding actually really fascinating is at the data warehouse layer. So the Snowflake versus Databricks conflict is really heating up. I don't know who's been following this with the benchmarks that were released a few weeks ago. You haven't, you should grab some popcorn and check it out. But the reason this is actually really interesting is that these companies did not start as competitors. They actually started with completely different stances on language support. Snowflake was one of the OG pioneers of being all in on the other end, Databricks started out focusing on much higher end, flexible, multi-purpose data science workflows. But look what's happened in the last couple of years. With Snowpark, Snowflake now has support for Java and Python UDFs, as well as working directly with data frames. And on the other side, Databricks is Delta Lake, which is basically just a SQL-driven data warehouse. So this might be a problem for both of the companies competing with each other, but honestly, it's great for all of us because what this means is that increasingly the most common analytics platforms are going to have support for multiple languages out of the box, making polyglot workflows much more accessible to everyday analysts. The last piece of this is actually pretty interesting and active right now is looking at the data workspace layer. There's a lot of innovation going on here, and I actually don't think we know where this is going to end up yet. That's actually fun for me personally to watch. But just some examples that exist today. On the notebook front, you have things like Netflix's Polynote and 2 Sigma's BeakerX. Interestingly, these are both polyglot notebooks that use the JVM, the Java virtual machines. They're actually using Java under the hood to power polyglot notebook environments. You also have workspaces, and there are a lot of really interesting products here. There are some established players like Mode, which has Python and SQL, as well as newer tools that are really innovating here. So one example is Sigma, which combines BI and spreadsheets in a really interesting way. Obviously, Hex also one of these, but I'm not really going to bore you with the Hex commercial here. If you're interested, just hit me up offline. Happy to chat about it. So that's where we're at today. But I think one of the big advantages that doesn't get talked about a ton about being polyglot by design is that you can really easily incorporate new languages as they're being developed. And there's a lot of really interesting stuff out there, both stuff that exists today, and I'm sure stuff that's going to be developed in the future. Some general purpose languages like Julia, there's domain specific ones like Malloy that was just released by Looker for describing data transformations. Another interesting entry is JavaScript, which is a very old language, but is increasingly becoming lingua franca for data visualization. And who knows what else is going to be designed in the future. At the start of this talk, we saw how over 50 years, we had multiple different languages, multiple different paradigms, and often these were adopted for years or decades at a time. And I think it's highly likely that over the next 50 years or so, we'll see a similar pattern of cycles of innovation and adoption. And so we want to be ready for that. And in my opinion, the best way we can be ready for that future is by adopting a polyglot, flexible toolchain today, right now. That's where I'm going to leave you for now. That's the end of my talking part of this. Sadly, as much as we like it to be the case, I just don't think one language is going to be able to elegantly tackle all of the use cases in analytics, and I think that's totally okay. There's a lot of new technology coming down the line that's going to dramatically improve our ability to operate in this increasingly polyglot. Yeah, so at this point, would love to have you join me over in Slack. We have some discussion questions. It looks like we have a lively discussion going on already. And yeah, just let me know where you think I'm right or wrong or what is going on in this space. And if you're not in Slack, feel free to hit me up at caitlin@hex.tech. Thanks everyone for coming.